Uh, Anyone, guys? What is population? So basically, a statistical population is refers to the entire group or group of individuals or maybe group of instance which are taken into consideration while we are doing any analysis or any type of experiment, statistical experiments. Okay, so there could be examples like all college students in Kolkata, or maybe all manufactured item in a factory or any production batch, and there could another example like entire population of a city. The generic population could also be considered as a population, but statistical population is a little different from what we conventionally mean by population, by the word population. So statistical population is just the collection or the collection of the entities which are taken into consideration while we are performing the statistical analysis. Okay, so there are so many characteristics. If there's a population, there's a group. If there's a large number of instances, there must be few such characteristics which are being considered and which are actually signifying different perspectives of the population. So these unknown characteristics of a certain population is known as parameter. Okay? So a statistical parameter is a numerical value, generally a numerical value, which is representing different characteristics of a statistical population, like population mean, population variance, kurtosis, skewness, whatever it could be. Like we can also call it raw moments or moments. Right? So these are my parameters. Now, our job as a statistician is to get the value of these parameters, as these parameters are not known to me. Okay, so whenever we are interested in doing any analysis regarding a certain statistical population, what we are actually intending to do, we are trying to get the values or the maybe approximate values of these parameters like population mean, population variance, kurtosis, skewness, and so on. So to find it, in terms of finding it, we can just take the whole population and calculate over it. But that's not always feasible, as population is often infinitely large or many finitely large. So it's not feasible for us to deal with such a population uh, to find these kind of parameters. So what do? We take a sample which is a perfect or homogeneous representation of the parameter of the population, and we calculate something based on that small sample uh, or not infinitely many or not that many large sample, and estimate the value of the parameters based on the taken sample. Okay, and whatever we are calculating, um, the calculated value based on the sample is called statistic. And whenever we are trying to estimate the parameter, we always estimate based on the statistic value. Okay, now what is the difference between parameter and statistic? So basically, parameter is the characteristics of the original statistical population, but statistic is totally calculated on the sample. So statistic signifies the characteristics of the sample we have drawn from the large population. Okay. Now, Now, based on the statistic, we can easily estimate the value of parameters. But is there only one way to do that? No. There are three different ways to estimate a value of a parameter. Okay. Can anyone tell me what are the ways? Like obviously one of them is hypothesis testing, what we gonna explore. But apart from that, anyone? What are the different ways to estimate the value of a parameter? So there are three ways. First one is point estimation. Second one is interval estimation, and third one is hypothesis testing. So let us take a uh, little more insight about point estimation. Okay, so what is point estimation? So in this method, we are finding the best possible singular value for the population parameter based on these statistics. Example, like we can easily, if a population is following normal and a normal distribution, and we have drawn a sample which is also following a normal distribution, we can easily tell that the population mean is uh, properly signified or properly represented by sample mean only. So sample mean is an unbiased estimator for population or estimator for population. So why we should be preferring this method? Because we should prefer this method because this gives us a precise and direct estimate. Okay, a precise and direct estimate of the parameter. But there should be some drawbacks as well. So in this method, we lose few information and estimation accuracy compromised because of this precise value giving tendency. So to overcome that, we come up with a different estimator that is called interval estimator. So in this scenario, instead of giving a single based value, we try to find a range of values within that parameter should be lying with a certain confidence. Like I have given a range a comma b, and I'm 95% confident that my actual population parameter should be lying within that interval only. In this scenario, we call it a interval estimator, and the confidence which I am showing is called confidence intervals. Okay. Any doubt so far?
Like sample which we will take will also be normal. Huh?
Uh, not necessarily, but what example I gave on the point estimation scenario, that was taken from normal population and normal sample. And even if for normal population, whatever sample I take, the sample mean will be a unbiased estimator. But in the scenario, interval estimation scenario, here two factors are coming into picture. First, we are going forward with a range which is a little lenient over the restrictions instead of giving single best value. And secondly, we are taking a confidence over the interval, so that it's not necessary that I have a 100% confidence. So we can include the probabilistic scenario in this estimated value as well. Okay. So it actually shows a precision and balance within the reliability of the estimation estimator. Okay. So these are two popularly used estimator uh, and estimation methods. And next we should go forward with hypothesis testing. So what do you do in case of hypothesis testing? In case of hypothesis testing, based on the data we have, we assume two things. We assume two things. One is null hypothesis, Another one is alternative hypothesis. So, and once we have assumed two hypotheses, one is null, another one is alternative hypothesis, we try to validate the data we already have with uh, sorry uh, we try to validate the data validate the assumption based on the data we already have, or based on the sample we already have. Okay, any doubt? Like what we are trying to do, you can resemble it as a courtroom scenario. Like someone has been accused, and the other person, someone has been accused, the other party should come up with more evidence to prove him guilty. Otherwise, it will not be accepted. Similarly, null hypothesis has been assumed as true. We have to bring data to uh, validate, or we have to come up with data, we have to come up with evidence to nullify that hypothesis. Otherwise, it will be accepted. So there are so many fields where we use it, like drug testing, statistical quality control, a huge zone of using statistical hypothesis testing. Social sciences, obviously, it actually helps us to take decision based on the data or the sample we already have. Okay, so there are two type of hypothesis testing. Like first one is parametric scenario, second one is non-parametric scenario. Okay, so what is parametric scenario? Um, what we were actually trying to find out, we are trying to find out the value of parameters, right? So the tests, all the tests are being uh, performed over the parameter only. We are trying to make assumptions on the values, possible values of parameters only. Now, in this scenario, if we are going forward with a parametric scenario, then the parent distribution or the population parameters are actually well defined. Like, I can give you one example. In parametric scenario, we can assume a scenario where a population is from is following normal distribution with some mean mu and some variance sigma square. Okay. In this scenario, if we perform hypothesis testing to just validate or find out the actual value of the parameters, we are actually going forward with parametric hypothesis testing. But what if we don't even know that what are the distributions or what are the structures or the parent distribution or the population distribution is actually following? Then in that scenario, we can only assume few parameters as median, or those parameters which are not based on the distribution, or it is called distribution free method. In these scenarios, if we are going forward with hypothesis testing, then we should make it a non-parametric testing scenario. Okay. First scenario, in the first cases, we all conventionally use chi-square test, t-test, and etc. etc. But in non-parametric scenario, we can use U-test, Mann-Houdini test, run test, Zonkere-Tapstra test, and so on, so many others. Okay, I guess what is hypothesis and how hypothesis testing is working is clear to you guys. Any doubt regarding hypothesis or the part I just discussed? Okay. Shukanna, I guess you can take over for the second part.
Yes, yes. Thank you.
Yeah. stopping the presentation.
Yeah. Okay. So almost just starting from where Samyuvrata just left, what we were discussing is purely what is hypothesis testing and how do we formulate different tests, or what kind of applications does it have. So exactly where he stopped at parametric test and non-parametric test, right? Just for a transition, parametric tests are those where you have predefined assumptions about your population parameter. Okay. Everywhere, as you just stated, everywhere, whenever you make a null hypothesis or an alternative hypothesis, it is about a parameter of your population. Now, what is a parameter? A parameter is something that defines your population, that you can identify, that's a characteristic of your population. Now when you assume something about them, they when you want to identify, when you want to test for something about the population parameter, that's when you use hypothesis testing. Now when you have a set of predefined assumptions to apply this test, in order to just apply this test, if you want a predefined set of assumptions, for example, maybe not in this scenario, but if you consider your general example scenario, consider a case where you want to test the average marks of student of your college. Okay, so it's a mandatory thing to know that the student must be enrolled in your college, right? That's an assumption that we are making. Any mark that we are henceforth considering are of students who are from your college, whichever college you are taking up the data about. So basically, you have a set of predefined notions, we have a set of predefined assumptions about your population parameter. Only if they are satisfied could you apply this test. Such tests are called parametric tests. They are actually, the issue with this is not every time can we see a real life scenario where these assumptions are followed. For example, if I say that if my assumption to apply this test is my data is following a normal distribution, of course there are so many non-normal scenarios in our surroundings, right? Not everything is normal. We may study CLT and all, but that doesn't mean that every characteristic is being normalized in its primary stage. The data behaves differently. That's why we have so many set of standard distributions. So, of course, when that assumption is not satisfied, the issue with parametric test is they don't give you the accurate results. They don't appreciate, or they don't really exactly behave the way we wish them to give. They don't give you the appropriate result. That is a problem with parametric test. Now what is a way to tackle it? Yeah, there are no assumptions, we can't probably go with it. So what would you do? The possible next possible solution is find a way to test the same hypothesis about the same population parameter on the scenarios where these assumptions about our population parameters are not satisfied. This is given by non-parametric test. So the alternative scenarios, that is much usable when you have a set of data that do not follow any kind of assumptions, or we can't even get them to follow those kind of assumptions. Like you can't transform the data and make it normal, or you can't do anything about it. In such cases, we use non-parametric test. But when this is an alternative scenario, then why don't use it always, right? We don't even have to check for the assumptions. But we can't use it always just because it needs a very large amount of data to give a reliable result. Yeah, it's true that it can be applied to any test, but the issue with it is because it is a non-parametric data, to understand the characteristic of it, to understand the behavior of it, you will need a lot of data, which is unfortunately not available all the time. So the advantage of parametric tests is they are standardized distributions. You get a set of results even for a small set of data, if even for a small, comparatively small number of data. when your set of assumptions are satisfied. Now, if that is not satisfied, your best alternative, your best choice is to go for a non-parametric test. But we have to keep in check or in mind that the non-parametric test gives a low power or doesn't give that much reliable results unless we have a huge amount of data. Now, what are the common testing procedures that you will actually come across in statistics to people, or that you generally lead to in any of your textbook, is the testing of average and variance, because they are called the location and the scale parameters, and they almost define almost every distribution, or you can actually define most of the characteristic of a data from the first four moments, and mean and variance are actually the first two important ones. That is what we usually test. But almost every time throughout your statistical analysis, what you will believe is the data that we have acquired is independent, and they are very purely random. There is no prejudices. You can completely apply the probability scenarios into each of your data. Now, to check if the data is actually random or somebody has given you a made up data or something, that's usually called a test of randomness, which is actually a part of non-parametric test. Similarly, you can find out tons of examples. Now, how do you pause a null and alternative hypothesis? We did say that the null hypothesis as well as the alternative hypothesis is actually some claim about your population parameter. So basically, what you wish to do is you want to make a claim, you want a particular statement made about your population parameter. Now, you want, on the basis of your data, you want to test if this claim is actually proven through your data as well, or is it just a fallacy made by the data, or is it just a fallacy seen to your eyes? Okay, that is what we need, always a backing. We need a proof that yes, this is indeed true. That claim, that, or it is indeed false, that claim, that is what is defined as null hypothesis. So whatever claim that you're making, that is what we define as a null hypothesis. Now, whatever is the opposite scenario to it, they are called alternative hypothesis. For example, the null hypothesis says that your average mark is, say, 70%. Okay, that's a claim that you're trying to make. You want to prove or disprove your data. You want to test on the basis of your scores that you have scored till now, based on all your test papers or something, or whatever it is. So you want to actually try and test for that claim using your data. Now, that claim is actually called as null hypothesis. Whereas if you believe that no, my average is about 85%, you can put that as your alternative hypothesis. So the alternative scenario that is possible, when you, that is not a favoring of your, or that's not exactly your null hypothesis, anything that contradicts your null hypothesis can be said to as a alternative hypothesis. Basically, anybody, any proper statistician would actually recommend you to either reject your null hypothesis, or not to reject your null hypothesis, because your alternative scenario is a very generalized one. It can keep on changing, or it can go ahead in different way, or same, for the same experiment, two people could put two different alternatives. So you cannot really accept the alternative, but for simplicity in our courses, we do accept our alternative. Okay, just to clear there. But basically, what you do is you are simply testing if your null hypothesis, that is your claim, is fair enough or not. That is, if your claim is true enough or not. That is all that you're checking. So what you get is, you either reject your null hypothesis, say that it's a not favoring claim, it's not at all advisable to go ahead with it. Or what you do is, the alternative scenario is, according to the data that is given to us, or according to the test that we have performed, we don't have enough evidences to reject this null hypothesis. Okay, that's what we do. We always either reject your null hypothesis, or we do not reject your null hypothesis. But yeah, there's nothing wrong in saying that your alternative scenario goes by accepting your alternative hypothesis for the time being, not in real life, for the time being. And Yes, the null hypothesis as well as the alternative hypothesis can be defined on any terms, like can be an equality sign, an inequality, or not equal to anything. It could go with anything. Like, yes, the null hypothesis should be an equal to sign. Otherwise, the alternative can take the opposite of it, which is not equal to. Similarly, greater than, less than can be alternatively used for both the scenarios. Um, good, like, okay till now? Or anything confusing? Yes. Um, do you want to ask something?
Yes, this side it is Orijit. Uh, I have a question about that non-parametric hypothesis testing.
Yes, yes.
So my question
Hmm.
is that suppose there is a production line and data is continuously coming.
Okay.
So whenever a new data point is getting added into that
Hmm.
data set, so
Hmm.
the distribution is keep changing.
Yeah.
That's true. So in that case, for any continuous data stream, we must
Hmm.
always use non-parametric test. Is it correct or am I wrong?
No, no, okay. If, particularly, what you are saying is we are adding upon our samples, right?
Yeah,
Like
yeah,
you have already have 10 samples, you are adding up 11, 12, 13. It's
yes,
keeping
yes,
on
yes,
top.
yes. Yeah.
Okay, if it is come, if we are taking sample from a single population,
Hmm.
the basic distribution does not change. It is actually the samples distribution that is giving you a little variation. But
Okay.
whatever sample that you are taking, it is from the basic population only, right?
Okay.
So
Okay.
the basic population has already a defined distribution. We are just
Okay.
checking for its parameter. We are
Okay.
not checking for the sample parameters. So no, you don't have to always apply non-parametric test on a continuous series case. Like if you are on a time series data, or if you are taking keeping on, if you are continuously taking data
Hmm.
in a definite period of time, or even in an indefinite period of time, you don't have to always apply non-parametric test. You will have to apply this non-parametric test only if your underlying population is not satisfying any of your assumptions.
Okay. Okay.
Like you are saying, right, you are taking your samples independently. Now
Yeah.
it is, suppose it is not that you are not taking it independently, like you are actually dependent on some changes, like you see some minute change in your sample coming,
Hmm.
that is when you pick your next sample or something like that in your products. Like it's a line of products according to you, so it's keeping on, suppose it's a machine, okay, it's a what a machinery product, something that's coming out of your line.
Yeah.
Now a factory product, so what happens is you only pick another sample if you see that there is some issue, some weight, some package issue or something there.
Yeah.
Only then if you're picking your next sample, that means you're putting a dependent scenario on that. You're not picking up it independently. Okay, only in such cases where the assumptions are not satisfied will you have to go for non-parametric test. Otherwise
Oh.
it's
Okay. Okay. Thanks.
okay. Thank you. Okay. Anyone else got any questions? Okay. Hope it's not there. If you have, you can actually raise up your hand anytime. Okay. So continuing. Now, how do you determine, or yeah, we said about all the stuff. We did talk about accepting your null hypothesis or rejecting your null hypothesis and not rejecting it and all that. Okay. Now, on what is a metric that actually helps you deciding to accept it or not? Okay, this is based on two things, or this is the two matrices that we always have. Now basically for any hypothesis testing, there are three constraints in a hand. One is sample size. Okay, it's always a sample size because not always we do have so much of resources in our hands to handle a huge sample size. That is our constraint. That is almost always our constraint. Now, that is fixed probably mostly according to the budget of yours or something. So you always have a fixed thing that I can take maximum of this much samples, and any statistical test would say take the maximum sample. Okay, there's no other go for you. That's what anyone would prefer. Now, you got a sample, you need to decide upon it. Now, what is a decision making thing? Now, if you are actually continuing on the same line that he said, what would a basic producer and a consumer. That's okay. According to me, that's the most easiest way to understand it. But yeah, what is a consider for any product? There are two perspectives, right? One is a manufacturer's perspective. What he wants is unknowingly he doesn't want any of his bad products to be rejected, right? He doesn't want a wrong decision to be taken ever. He always wants, like, even unknowingly, because that's a loss for him. So he doesn't want, if it's a good product, he does not want it to get rejected at all. A bad product is fine because it's his fault, but if it's a good product, he never wants to get it rejected. Very similarly, from a consumer's point of view, if you are the person who are consuming it, you do not accidentally want to get a bad product in your purchase, right? You always want the most long lasting reliable product in your purchase. You don't want even an accident lot that has come up which has got a defective item to come into your hands. This is always a two perspective that is dealt with any hypothesis testing. So one is you don't want a good lot to be rejected, which is the producer's point of view, and as a consumer, what you would prefer is you don't get a bad product. Okay, this is what actually denoted by the size and power of a test. Okay, now what is size, which is actually denoted by alpha? These are called the two types of errors also. So what is type 1 error? Type 1 error is you are rejecting a true hypothesis. Okay, you are rejecting a true hypothesis. If you are analoging it to the other case, you are rejecting a good product. Okay, this is the consumer's producer's risk. He doesn't want it to happen ever. Very similarly, the second metric goes by type 2 error. That is, you are accepting a null hypothesis when you know it's false. Okay, you are accepting a false hypothesis. Now, that is, if you compare it to the other scenario, you are accepting a bad product into your lot or a defective product into your lot. This is called the type 2 error. Okay, you know that the alternative scenario is a better one. You know that your hypothesis is false, still you are accepting it. That is type 2 error. And the type 1 error is you are rejecting it when you know that it is a good product or when you know that the null hypothesis is true. So these are the two matrices. Always what everybody wants. We always want alpha as well as beta to be minimized, right? That's what anybody would prefer any day. We don't want an alternative scenario. We always want alpha and beta to be uh, minimal in our test. But in real life what happens is, even though when you can generalize and say that if alpha increases beta decreases or something, there is no definite relation like that. Okay, both are two different types of errors and you cannot exactly define that it is so happening. But the issue is you want to minimize both of it. Generally, in the general scenarios, what we do is, for a fixed alpha, you try to minimize beta. So you have three constraints in that n is already fixed in the first place. Alpha is what you fix almost always, like all the time, and you try to minimize beta. Now you can say again the size of a test in another format. Say that the size of a test is simply the risk that the producer is actually willing to take. For example, maybe think that you want to, you are the producer, you are the manufacturer of the company, and you say that maybe I can tolerate a 2% risk. It differs from product to product, literally, because for a medicine, you cannot, like if you are in a pharmaceutical line, it's impossible, right? You cannot carry a 2% risk with you. But in a stock market, based on your financial status, maybe you're willing to take a 2% risk. And other case in pharmaceutical, maybe you're only willing to take 0.5% or 0.05% of risk, because the medicines can be fatal at times, right? So based upon the seriousness of the situation, there is a risk with which the producer is willing to act upon his decisions, or accept the result of your hypothesis testing. That is what is denoted by alpha. Okay, so that is what is denoted by alpha. And the other case, the very opposite scenario, the other way, where you're buying a headphones for say, you are willing to take what, probably a 2% risk, right? Or even a 5% risk. Maybe it's your nearby shop, you go there repeatedly, so you're okay. If the product is bad 2 times, 4 times, you are like, okay, it's not his fault, maybe accidentally happened, it just ran for 1 year. But then if it repeatedly happen, or if it happen always, you'll not rely on that shop anymore, however nearby it is, right? So there is a risk that as a consumer a person is willing to take, as well as a producer one is supposed to take or willing to take. That is what is always denoted by alpha and beta. Now, a power of a test is actually 1 minus beta. That is the ability of the test to actually identify that your alternative scenario is a more favorable scenario. Actually identify that your null hypothesis is false and you are going to accept your alternative. Okay, or what do you say, you are accepting, you are rejecting your null hypothesis on the knowledge that it is a false statement. That is called the power of a test. So the power of your test, your whatever test that you're conducting, to identify that your null hypothesis is a wrong statement correctly. Okay, to identify correctly that your null hypothesis is a wrong statement, and henceforth you are rejecting the null hypothesis. That ability of the test is actually what is defined by power of a test. Okay, so to just be on a clearer basis, you want to make a decision about your null hypothesis, there are only two possible ways to decide upon it. Either you reject your null hypothesis, or you do not reject your null hypothesis. If you reject your null hypothesis, again it could happen in two scenarios. One, where your null hypothesis is true, that is when your claim is true. Now that is a wrong thing to do. Your claim is true, but still you are rejecting your null hypothesis, right? That is your first error, called the size or significance level of the test, that is denoted by alpha. Now if you are rejecting your null hypothesis when it is false, then that is a right decision, there's nothing wrong with it, very good, your test is performing well. Now coming to the alternative scenario, you accept your null hypothesis. Again, that can also happen in two scenarios, once when it is false and otherwise when it's true. So if you're accepting your null hypothesis when it is false, sorry, you're accepting your alternative when you're so accepting your null hypothesis when your alternative is false, that is also a right decision to take. Okay, it literally means that your null hypothesis is just right? So that's also a good decision. The same thing if you are accepting your null hypothesis when you believe that your alternative is a better scenario, your null hypothesis is a false statement, then that falls into the second category of error, the type 2 error denoted by beta. And 1 minus 1 is the maximum probability. So 1 minus of your total sample space probability is 1. So 1 minus beta. 1 minus type 2 error is actually the ability of the test to identify a decision correctly. That is called the power of the test. Is it okay? Because um, we'll just see using this graph. Maybe after that you can ask a doubt regarding the same topic. What you usually say is this is your actual null hypothesis and this is your alternative hypothesis. Okay, the first heap pile, the first bell-shaped curve shows your null hypothesis and the second case shows your alternative hypothesis, as the figure itself says. Now you are actually going to take a sample from this whole distribution. Now it falls into anywhere into the left side of this line, the first line that you can actually see. If it happens about onto the left side of this line, then you're on the safer side, right? There are like most of the sample is coming where the null hypothesis is favoring. Similarly, if it's coming on the right hand side also of the alternative graph, okay, if it's coming to the right hand side of this line, then also it is safe enough to say that it will come from the alternative. You can make a probably a much better decision upon it. But always the issue arises when your data falls on this in between region. Okay, your data is falling on this in between region. That is when you will have to make a decision. That is usually when we will have to make a call upon it. When you are making a call upon this, what you say is that this green area, this what do you say, the glazing green area that you can see, that is probably the risk that you're willing to take. That is, it is probably coming from the null hypothesis, but you're stating that your null hypothesis is true. You actually took a sample under this population only, but it is to the edge of this population. It just happened to be at the extreme end of this population. Just because of that, you are willing to take that risk. You are just simply willing to take the risk that, okay, if you are taking a sample from this, I am willing to accept that there is like this risk is involved in my testing, and okay, fine, I can just rely upon the result, because majority of the time, like the almost this much of your time, sorry, my lining is bad, but yeah, majority of the 3/4 the time. So sorry.
Shrikana, it
Okay, sorry.
is breaking a little.
Yeah, sorry. Like in between, I guess I lost my connection. Sorry. Yeah. No, it's okay, right?
Yeah. Sure.
Perfect. Thank you. Any doubt till here? Significance and power? I'll actually like next is p value. So before that, let's not get confused. Can you actually say, is there anything, any issues? No? Cool? Good? Okay, thank you. Then we'll see what is a p value. Yes, we said that we always wanted to minimize alpha beta, right? We have a fixed constraint of n, we want to minimize alpha and beta. But the issue is, it is upon the company or the business organization that is giving you the data to decide what is their alpha, right? We cannot randomly fix a alpha. We just said that we'll fix n and alpha, we'll try to minimize beta. That is a standard procedure that we use, that we generally follow to test our null hypothesis, to test our data, right? Now, but to do conduct our hypothesis testing. But the issue is, not always is it reliable, or not always it is in the statistician's hand or your data analyst hand to check what is the alpha, or we are not the deciding authority for that. It actually just depends completely upon the business organization that is dealing with it, right? It is their decision, it is their final call to see what is the alpha that they are willing to take. Now, in such a scenario, what usually every statistical test provides is, you calculate the p value of your test. It is nothing but the alpha value only, but it is actually saying how much of an evidence do you actually have against your null hypothesis. Okay, that it simply means that if you observe a p value around this area of your graph, okay, you're observing a p value around the right end of your tail. Suppose your alternative is again a right hand tail, so you are observing a sample from this area, then that means that it is less, like there is a very less likely probability for a sample to come from this area, and the risk that you're possessing is higher. Okay, there is so much evidence against your null hypothesis. Okay, the risk was this critical point, this dot, green dot. I don't know if I can draw around it, but yeah, this observed value, this is your, this wherever this blue starts, right, this critical value, that is your alpha value, that is your significance level generally. And any value less than the significance level, okay, less than the alpha, that would say that this is from where your observed sample is. It is a very unlikely observation, and that would give you a very strong evidence against your null hypothesis, but it is upon you to actually determine if you want to accept it or not. Okay, it is simply, p value is simply the amount of evidence that you have against your null hypothesis. Now, to maybe sum up or something, what are the general scenarios that you can see, or that you can apply hypothesis testing in your real life? You can think about it in your own words. Just what I forgot the name, but the student who asked it out, yes, to see if your product is conforming to your standards, to see if a medicine that you have produced or a new treatment technique that you have produced for a particular disease is effective or not. So what would be your null hypothesis? Probably it should say that the treatment is not effective against the null hypothesis that yes, the treatment is effective, right? Or if you're testing the insulin level, it should go by insulin level is equal to the standard level, or if the treatment has or the medicine has actually helped to reduce the insulin level in a human being or a patient, right? That is one way of formulating your null hypothesis, and this happens in real life all the time. You are supposed to really test a medicine for some 5 year 7 year period before it is actually introduced into the public. Okay, so all these, whatever, this is just my choice of three examples. You can think of tons of such examples. The second another thing is the product actually conforming to your quality? For example, you want to test, your standard procedure says that the refill in your pen, right, the ballpoint pen that you use, the refill should actually be what, 5 millimeter in diameter. It cannot go more than that. Now you want to maximize, what you can do, you can actually do a plus or minus 0.2. It could go by 4.8 to 5.2. That's the interval that you're willing to take, right? You actually want to see if all of the refills that you have produced are actually conforming to those standards, are actually uh, adhering to those standards. That is what, this is also one way of confirming your quality, like your product is satisfying the quality standards. Okay, and similarly you want to test if your if the policy that you're introducing will actually bring no change, that would be your null hypothesis, or it will actually bring a positive change. So before implementing any of it, you want to see the impact factor of it on your society, right? You cannot simply directly apply something to a general public where it affects tons of people. So you want to primarily check if it's affecting positively or not, and then only you get the approval to it. Okay, these are just few scenarios that just randomly came to my mind, but you can think of tons of such scenarios. So I'm quickly summarizing the whole thing, what we went through, just my section. What he said was population statistic, hypothesis testing, how do you estimate a estimator, and then if I'm just quickly summarizing it, what are parametric and non-parametric tests? When you work under an assumption, it's parametric. When you work without an assumption, it's non-parametric. Whatever claim that you have about your population parameter is called the null hypothesis. Any sorry, any statement that contradicts your null could be called the alternative hypothesis. While doing the procedure of hypothesis testing, you mainly encounter two types of errors, which also serves to be the metric of your result, denoted by alpha and beta, called the type 1 error, where you actually are rejecting a true null hypothesis, which is actually denoting a false positive scenario, and the type 2 error, which is actually giving you out a false negative scenario. That is, you are rejecting, sorry, you are not rejecting a false null hypothesis. And the last portion that we elaborated was on p-value. It simply says how much evidence that you have against your data, from your data, how likely is this observation to happen, how likely are you to get this sample value from on the basis of your null hypothesis. If the null hypothesis is true, suppose your null hypothesis is true, how likely are you to observe this particular sample? That is what p-value says. uh, Thank you for the session. That's the summary of hypothesis testing. Please ask any questions if you have. I rushed through the last one, I guess, but yeah, please, if you do have any questions, please ask. Any?
Guys, if you have any question, you can go ahead. And if you guys are wondering, is that all about hypothesis testing? No, we'll be having another session on hypothesis testing. That is on maybe at the month of December.
Yes.
Yeah, go ahead.
This is Orijit.
Ah,
So,
yes.
can you please share these slides if it is
Oh,
Yeah,
possible?
yeah, Sure, the video and the
Okay.
slides will be shared and is uploaded
Okay.
and shared in the. Any more queries, guys?
Hello.
Yes, please.
So can you give just a single example where from end to end, like formulating a hypothesis to analyzing the output? Just a single example, in short.
Okay, maybe what we were just discussing, right?
Hmm.
You found a medicine. Okay, you found that. Okay, there was paracetamol beforehand. You didn't have crocin or you didn't have adodo. So
Okay.
before introducing it, what would you first do is you will actually see if there is a positive. You want to actually test if there is a positive impact on it to the society, right? To the people. So the first step would be actually defining what is your population parameter. So maybe you are saying that the average temperature value would
Hmm.
reduce. Okay, so the average temperature of a human body after the medicine is what you are actually going to test, or is it effective or not? That is what you are going to test. So
Right.
first step is you would actually pick a sample. We will pick up from the whole population. The first step would be to make a sample, a reasonable number of people you will have to say, and then make two groups out of it. One where this is how usually it happens. So one
Hmm.
you where you give paracetamol, to the other group you are giving crocin. You want to see if there is an effect, right? So
Right.
probably you will make two groups. One will be the ones who are actually giving, you're just given the paracetamol ones. The other ones you will the improved medicine, whichever is given to them. Now what you will do is you will keep on observing the average value of all the people of both the scenarios, like both the groups, whatever
Hmm.
control groups that you have. Now
Right.
what you would do is the first step is to see how many samples that you can. That's the first constraint, n. The second step is if it is just your own company, you can fix it, what is the alpha value that you are willing to take. So probably you're just willing to take a 1% risk, or even say 3% risk, because
Hmm.
uh, crocin doesn't have that of a huge side effect. You're not a fever, you don't have so much of side effects if it's just a casual fever. So you're
Right.
willing to take a 3% of risk in it. So your alpha value is 3%. What you
Hmm.
would do is from both the control groups that you have, you will try to get the average value, and now you will claim that as your null hypothesis would be claimed that there is no improvement. Usually the null hypothesis is taken to be the negative value or the negation claim. So what you
Hmm.
say is that you do not there is no change, there is no improvement with the new medicine. That would be your h naught. And the
Hmm.
alternative scenarios, you can positively say that there is a positive change, there is a huge reduction in the temperature, there's a quick reduction in the temperature, something like that, or the disease is contained easily. That would
Okay.
be your alternative hypothesis. Now, from the average value that you have obtained in terms of time or in terms of the temperature, you would
Hmm.
put that into the test. Now, if it satisfies the parameter, all the assumptions of your parametric test, whichever test that you are applying, usually
Hmm.
you apply t test. If it's just an average, you apply the sampling distribution called t, which
Hmm.
follows a t statistic and all. It is just testing for the mean value. If it just says if your population parameter is actually having this particular mean or not. That's what t-test actually tries to tell us. So you would actually test that t statistic, and upon based upon that, you will reach a conclusion. Like the t statistic would give you a value, and you can use a t tables and compare it and reach up the procedure. You can do the actual testing procedure and reach a conclusion that whether yes it is you can reject the null hypothesis that no, we are actually having some other impact on it. It's not a indifferent scenario, or you
Hmm.
can just completely accept the null hypothesis. You don't reject the null hypothesis with this particular cohort, with this particular group of people that you have, and conclude it like that. Or you can just recommend that no, we want more people, like more sample points to reach any conclusion. If you really want to insist upon checking it again, you can just reach a conclusion like that. This is how the general hypothesis testing procedure goes. Yeah, you now again, I simply state a t test. Now if it is not t, you can't, the assumptions are not followed,
Hmm.
the samples were not independent. then you will have to go for a non-parametric test to do the same procedure. Like the henceforth procedure would be same. The only thing is you will, based upon the assumptions, you will choose whether you need to do a parametric test or a non-parametric test.
Okay.
Okay. Maybe we'll try, if it's interesting, we'll try to get an example at some point to show you how it moves.
Okay.
Yeah.
Seems good.
Thank you. Yes, anything else?
Any more questions?
Um, yes, may, okay. Thank you.